Happy Sunday, YouTube. What's up, everybody? How's everybody out there doing? I'm Greg from GregsTutoringNYC at gmail.com. Give me 1 second here. I'm trying to get this on my phone so I can see the chat better. And it's not showing up. So this is a series I'm covering from grade 3 to grade 8. Actually, it's saying the YouTube is failing, so I'm not even sure this is live. All right, give me 1 second. I'm going to refresh this. So if this is live, we're talking about the hardest math problems at each different grade level. I'm up to grade 8. I think this is part 4, if I'm not mistaken. And we're sourcing from, okay, I don't see this coming up on either my computer or my phone. Let me see, the testing, 1, 2, 3. Give this 1 more second. If I don't see it, I'm gonna delete this and start over. Yada, yada, yada. Hopefully everybody's doing all right. Guys are in the thick of school already. It's already October 17th. Yeah. SAT is coming up in 2 months. Hopefully you guys who are prepping for that are doing all right. This is actually prerequisite and requisite material for the SHSAT. Some of you guys are taking the TJHSST next month, or the CHSEE, the HSPT. Nope, this is not happening. All right. Give me 1 more second. Something's spinning here. Let me see if it shows up. Okay, wait. It's finally showing on my computer. Let me try the phone again. And it's on the phone as well. There we go. All right, let me see if we're live here. 1 more second. Something's spinning here. All right, there we go. Let me set this up for the chat. I have a phone holder which broke, so I can't really see this too well, but this is what we're going to do. So again, I'm Greg's Tutoring from Greg. I'm confusing myself at this point. All right, let me fix my screen here. Let's just jump into these problems. No more banter. All right, let me see here. Where are we? All right, so the last time we finished whatever this question was about, the crane lowering down. And I wanted to make a few more points about that question. By the way, we're going to go about an hour. Please like and subscribe. I know this is kind of a busy point for you guys. So you're in the school, thick of things for school, and you got assignments, projects already. A whole bunch of you got quizzes. I have a student who had like 15 exams already. Really, really mind-blowing stuff. I'm seeing this is not in focus either, so hopefully it's coming in focus for you guys. Nope, wait, let me see. It's coming in focus on my phone, but not on my computer. Believe me, that's YouTube doing that. I'm not sure why that's the case, but this happens kind of often. All right, so what I want to cover, just get my tablet going again, is some of the stuff I wrote in red here. So the traditional equation of a line is this y equals ms plus b thing. And I mentioned something at one point, I think when I was talking about the answer, because it has a minus sign here. And that there's other forms. In fact, I think I pointed out this form b here, right here. So this plus right here doesn't mean the actual equation has to have a plus in it. Because you can have a plus b, and b is actually minus 9. So you might, if a was 7, you would have 7 plus minus 9, which is the same as 7 minus 9, because we have identities and stuff like that. So some kids get bent out of shape saying there was no plus sign there, so how could choice C and D be the answer in the original thing here, and things like that. It's because it's talking conceptual. So it turns out we can have y equals mx plus b a here. We could also have form b, and we could also have, because there's an implicit plus sign here in the y equals plus mx plus b. For the same reason, choice C is valid, because we can have a minus there, right? In fact, I left off a category. I'll call it CD, which is y equals minus mx plus b. Right? So the underlying equation, which is form A, it's the same no matter which way we approach it. And whether we put something here and here on each one, it doesn't matter. So that's why we can get A, B, C, D is the same. And furthermore, we can flip the order. So if the original thing is A, y equals mx plus b, that's the same because we have identities that happen in arithmetic. We can also say b plus mx. So that's choice D down here. And for the same note, we can put a negative on the b's, right? So there's also then a choice DE, I'll call it, which is y equals b minus mx. Oh, by the way, I noticed some of this is not coming on your screens. All right, sorry about that. All right, so basically what it means is just y equals mx plus b. That's not to be taken literally, because mx can be plus or minus and b can be plus or minus. That's really where this is going. The other thing is I did the visual here. This here, we visualized the problem, okay, by doing that there, right? But I also want to show you basically what a graph of this problem would be. So again, let's just read the words real quick. A crane lowers something from, it started at 270 feet above the ground at a constant rate of 2.56 going downwards, okay? And then what is the height above the ground after S seconds? So this means at some point, the concrete block is going to be on the ground. The height's going to be 0, right? So if we, let me erase some of this here for the choice that it was. Okay, so if we look at C, which was the answer, it's starting at 270. And we're going to subtract that, the number of seconds. So the question is, how many seconds will it take till that actually hits the ground? So if we go here, that's what we're going to try to figure out. We're also going to visualize it, right? So if you notice, if you look at the equation, again, we're looking here. Whoops, here. What we need to try to figure out is how many groups of 2.5 seconds will H end up being 0? All right? And we can do that by doing 2.5 into 270, which means it's 25 into 2700. And when we do that, it's 108. So in other words, 108, if we come back down to here, 108 times 2.5 is 270. So in 108 seconds, it will have a height of 0. Okay, so if we graph that, it means if we come here, the green line is the equation of the graph. Okay, the red lines are the equations. So right here, this dot right here, that I'm making larger and larger right now, that's 0 to 70. It means the crane originally has the block at a height of 270 feet. All right? So this is the seconds. And over here is the height. Okay? So based on what we just did over here, it means that 108, which is the dot here, at 108 seconds, its height is 0. So that's the dot right there. Okay, and if we just connect the two of them, it gives us the green line. Now this arrow here keeps going. However, it can't fall lower than the ground because the ground's there. But if, for instance, there was like a net or something there, you could argue the concrete block could fall through the net and keep going. So that's not the context of our problem. So technically, this is in here. So even though we drew a line, we end up having a line segment from between the two red dots. So that's pretty much what's going on there. All right, let me just make sure we're actually still live, especially because we had problems starting up. Yes, we are. Welcome anybody coming in if you're catching this in replay. Talking about a problem we solved the last time I was here. And we're going to go for about an hour, 45 minutes to an hour here. Depends on how my throat lasts and a whole bunch of other things. Okay, so the next question is going to be this 40. Oops. Okay, function P. Let me just make sure this is fitting on the screen right. Yeah, it seems to be. So function P is a linear function. So as soon as you see that, with the y-intercept of 5, right? We already know we're going to start out with this y equals mx plus b thing. And there's other forms of an equation of a line. I usually prefer this one, and especially since that's the form they're giving us that in. We didn't get up that far, but we can see that already. So once it tells us there's a linear equation, we can just basically pop that out. That's one of our givens. There's a linear function, therefore it has a linear equation. It says the y-intercept is 5. So the y-intercept is right here. That's the b. Okay? So it's plus 5 then. We don't know the slope yet. Okay? It says function q is defined by this equation here. So this is q. So they give us everything for q. They're giving us the slope is minus 1/3, and the y-intercept for q is 4. Okay? What we have for, this is function p, the one I wrote over here. Okay? All we know is the y-intercept. We do not know the slope yet. And maybe we don't need to. Let's see what the question says. Let's go back. P is a linear function with y-intercept of 5. Function q is defined as follows. Which statement must be true about both? So we have no idea what they're going to ask. Both functions have the same slope. So because they didn't provide any dots and any coordinates, we can't make that thing. So this doesn't say can be true. It says must be true. So therefore, the choice can't be A. Both functions have a negative slope. We know q does. We don't know what y has yet. But again, without coordinates and some other information, it says must. So it may turn out they both have negative slopes. Certainly q does. We don't know if p does. We can't guarantee that it must have one. So for that reason, b is out. Okay. The functions will have the same input when y is 0. Well, if we look at q and y is 0, right, that's 0 equals minus 1/3 x plus 4. We could subtract 4 by both sides, so we get minus 4 equals minus 1/3 x. And we multiply both sides by 3, and we get minus 12 equals minus 1x, and we divide by, so we get x equals 12 there, right? We can prove that if we throw x into here, we get minus 1/3 of 12, we get 4 minus 4, and then minus 4 plus 4 is 0. Okay, so that's true. What if we come over here? We can't do that because we don't know the slope, so we can't figure out x. So C is no good either. Okay. And then it says the functions will have different output when x is 0. So if we go to Q, when x is 0, we're throwing this away. So when x is 0, y is 4, right? When we come over here, even though we don't know the slope, if x is 0, that eradicates this whole expression here. And then for p, y will be equal to 5. So they do have different outputs. When x is 0, q is y is 4, and when x is 0, y is 5. So then the answer becomes D there. Okay? 41 is not one of the problem questions, but I'm going to do it real quick. So line K is a line of best fit. Okay, so each of these has its own K that's drawn on a scatter plot. Okay, the data shows a strong linear association. Strong, that's key. It's not just nonchalant, it's not erroneous, it's strong. Which scatter plot best represents these data? Which data? Strong association. Okay, so if you just look at these, because all the dots are below K, and the line of best fit should at least go through them in some manner, but it's above them, this is out. Okay, this is the opposite. All the points are above, so that's no good for the same reason. Okay, all right, so now we're going to look at B and D. Okay, so these do have lines going through the dots. So because it said strong, it just didn't say any association whatsoever. It's talking about super strong. So we kind of want to just look at maybe the number of dots. So the number of dots alone doesn't do it, but we have 1, 2, 3, 4, 5. That's almost there. So let's say it's on line 6, 7. So we have 7 above the line, and we have 1, 2, 3, 4, 5, 6. We have 6 below, and these two are both kind of near it. And then we actually have 3 points. This one here, this one here, this one here, actually on the line. So that actually looks pretty good. If we come over here to this one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 on this side. 1 second, this is syncing. We have 10 on this side. And we have 1, 2, 3, 4, 5, 6, 7. We have 7 over here. These kind of groups here are both kind of equal on there. We have one that's super close to the line here. Okay. Now, even though the 6 and 7 was close, that alone shouldn't be the determination. Because if these 10 were closer or further away, they may counterbalance the 7. So we only, now that we see D is very close, and it looks like it's really reasonably distributed, right? Choice D. But on B, they're kind of further away, and they don't seem as distributed where 2 can kind of match up to each other. So for that reason, B would be out. This one's kind of a tough one. At least know enough about this to be able to know your choices of B versus D. Okay. All right, so there's a lot going on in this problem. So let's just kind of look at it, if I can get it centered first. So we're going to look at the illustration first and see what we can grok out of it. And by the way, I believe I didn't put it up, but the choices have a lot here. Let me just make sure this is centered on you guys' screen. Yes, it seems to be. So we have an x axis, a y axis, right? We got x, and we're checking this in milliseconds. There's no title for this at all. We have a line, this line here, which I'm going to call QT, right? QT. And we have line segments even because there's dots there, right? There's actually dots denoted. We have an intersection right here. They're noting that for some reason. We have an intersection here. This line goes through the origin, right? This is a regular coordinate geometry setup. We have MN here. Okay. We have JK there. Okay, we don't know what they're going. This could be an angle question. It could be the length of a line question. We're going to look at the x-axis. That's by ones, 1, 2, 3, 4, 5. Y is also by ones, 1, 2, 3, 5. Want to make sure if it asks for area or something. And we think this line, MN and JK, they look parallel. Okay, in fact, they are, because it's 2 up. MN is 2 up, and it's a straight line going across. And JK is a straight line going across, and it's 2 below. So the equation of JK is y is minus 2, And the equation of mn is y equals plus 2, or just y equals 2. So we don't know what they're going to ask. There's a lot going on here. All right. So what I'm going to do is I'm going to erase all my notations because we don't know what they're going to ask. But that's what you're supposed to be looking for when you look at this. This is so busy. I don't even want to guess what they're going to ask for this question. There's just so much going on in this illustration. But we looked at it mathematically. Let's just pop this down slightly. It says in the diagram below, MN and JK are parallel. So we already thought that, and we also already confirmed that, and are intersected by QT. So they're talking about the intersection is at R, point R, and at point S, right? That's where QT intersects MN and JK at R and S respectively. Okay, so that's what that means. So what we're going to do now is scroll this up slightly so we can get the illustration. Okay, so it says which transformation. So you guys in grade 8 learn about transformations. In grade 7, some of you may know this, but in grade 8 you don't. And by the way, those of you in grade 7 should be looking at all these grade 8 problems I'm doing, because if you're proficient trying to get into better schools and better high schools and so on, this is your next step. And by the way, the SHSAT formally only considers grade 7. So these are theoretically considered extra problems, but we all know that it branches out further than that. And often what happens in your classrooms is not what's going on exams, even the New York State test, which this is from, by the way. So which transformation could be able to show that angle MRS is congruent to JST? So congruent is a technical term. It means same size and same shape. So if MRS was 50 degrees, then JST is 50 degrees. So the middle letter on an angle like this is the angle itself. Same here, S. So we're going to go M, R, S. So that's this here, okay? Because there's 4 angles here that are R. There's this one here, 2, 1, 2, 3, and 4, okay? Is also to JST. So J is here, ST, so they're talking about here, okay? Right? The middle is the actual angle, and we work from the coordinates. So it says start from M, go to R, and then go to, where's this? I got lost here now. S is the next point. S is over here, okay? And then the other one is the same thing, start at J, S is the middle, and then end up at T. And that's how we know what angles they're talking about, right? Because normally we have concepts and we need to understand them. This would say a square, and I said this was point T, and I said what's angle T? A lot of you would say, well, since it's a square, it's 90. But there's also this angle here. This is also T. So we have to talk about whether it's the inner, and by the way, that's 270, whether it's the inner angle or the outer angle. That's why we say what's the measurement of point, the angle T inside the square versus outside of it, okay? So, so which transformation could be used to show that MRS is congruent? So first of all, you need to understand that they are congruent, that the angle here and the angle here is the exact angle. So let's say that angle is 200 or whatever, right? You can see, no, not 200. It'd be actually it's a 45 degree angle here. So we have 90 plus 45. It's actually 135. It's not asking us to do that, but both of them are 135 degrees, right? The way I did that was that, just take another quick sidebar. If we're looking at this right here, okay, the line goes through that clearly at a 45 degree angle. So this here is 45, and this is 90. So 90 plus 45 was 135. Okay, this is all your prowess. This is all the mathematical proficiency and fluidity and numeracy and no hesitation. All these things should be just coming immediately and natural to you guys, because that's what they're asking you to do, right? All right, so where are we? So they're definitely congruent. They're both the same angle. This happens here too. We draw the square there. We can see that's 90, and this is half of 90, which is 45. So we can see they are indeed congruent. They're the same size and shape. So they're asking us, here's what they're asking us. How can I take this angle? If I took this angle on the coordinate grid and I shifted it down to there, okay, how could I do that? Right? How can I get that angle down if I actually dragged it into the other point? So let me try to put the 4 choices here for you guys. I wish this whiteboard had a. Actually, can I do that if I move that? Yes, it does. Okay, wait a second. I didn't know that till now. All right, I can move it by pixels. So I'm going to bring choice D all the way down as far as I can get it. And even though it cuts off the top of the thing, we can still get angle R and angle S showing. So if, let me erase everything I have here, just so we don't get clutter again, so we can actually visualize the transformation. So choice A says reflect MRS, so that's this angle here, over the x-axis. So this is the x-axis here. So if we reflected it, that would actually bring the angle here okay, and it would be right here. Okay, if I just took if the x-axis was a mirror and I reflected it, this angle would transform down to straight right there, right here. Okay, so it's not A. Okay, it says B says rotate MRS. So let me get rid of this. Rotate MRS about the origin. So it's saying if we took this as our point, if this was a string, if we had a string from the origin to S, and we rotated it about the origin, either clockwise or counterclockwise, it's not telling us. So if we rotated this, we would end up basically getting a circle, right? So if we rotated that, would we end up getting that? So the answer is no. It just, there's nowhere that it ends up over here. Okay? In fact, it would be here. Would be where it would end up, right? If we turn this 180 degrees, or basically turn this figure upside down. If you rotated this, if this is on a piece of paper, completely upside down, we would get this angle, this angle here, coming over here. So that's not JST. That's RSK. Okay, so that's not it. Okay, now it's saying, because we're trying to, let me get rid of the clutter again. So C says translate this down. So let's bring it down to here first, and then to the right. That seems to work. So it doesn't tell us how much to actually do it. And then D, just to do the completion, says dilate MRS by a scale factor of 2 with the center at R. It's already centered at R. So if we dilate it by a factor of 2, it's going to be in the same place. It's not going to move. The center is still R. So there's really not any dilation here. The angle is already itself. It can't get bigger than itself. Okay. Dilation means if we took a shape like, let's say, a square here, okay, and it was origin there. If we were to dilate this square by a factor of 2, it would become that, assuming this was the origin. It stays the origin, right? But in this case, we're just talking about an angle, all right? So there's nothing else going on there. Hello, are these questions for the 9th grade SHSAT? Do you need to know this for the SAT in December for 8th grade? Can you do SHSAT tips? Yeah, I'm going to start doing some SHSAT streams again. I have hundreds of videos already with SHSAT material that you can grok. If you go to GregsTutoringNYC.com/SHSAT-FAQs, F-A-Q-S, you can see a link to many of them I tried to organize there. So the question is, are these kind of questions on the SHSAT? Yes, they are. That's one reason why I'm doing them. We're also on a whole bunch of other tests. There's a problem in doing these videos, which in these ones are actually generalized and they're useful across a whole bunch of different stuff, even including not even doing tests. So this is really grade level, grade 8 stuff, which will be on the SHSAT 8 and the SHSAT 9. So it will be on both of them. All right. That said, this might be an easier question on the SHSAT 9, and perhaps a harder question on the SHSAT 8. So we have this kind of yin-yang that happens between the questions. There's an overlap between the two exams. So a hard SHSAT 8 question might be an easy SHSAT 9 question, and vice versa. And then there's also outlier questions where all of a sudden the SHSAT will put what appears to be a terribly easy question. And the SHSAT 9 might do that too. So the answer is, are these questions for SHSAT 9? Yes. Do you need to know this for SHSAT in December for 8th grade? Yes. Can you do SHSAT tips? I am. Plus, I'm going to be doing SHSAT specific videos as well. This is still a SHSAT video, even though it's general. All right. So this is prerequisite/requisite material. Anybody out there catching this, please like and subscribe. I'm here to help y'all. All right, so let's do the next question. I'm not sure where that came in. 12:51. That was live. Let me see how long I'm going here as well. So I got about 37 minutes. We'll do maybe 2 more questions. Let's see how long they take. So if you notice, a lot of these are dealing with the equation of a line. These are less centric for SHSAT 8, but very centric for SHSAT 9. So SHSAT 9 will talk about equations of a line. In SHSAT 8, it doesn't necessarily mention equation of a line. And by the way, when I'm talking about SHSAT here and stuff like that, it also applies to the TACHS, the Bergen County Academies test, the Hunter College High School test, the CHSEE, the HSPT, the PSAT, the ISEE, the SSAT. All these tests are dealing with some of the same notions. Is this on the SHSAT? Why isn't reflection and transformation on other SHSAT tests in the past? It has been. If you go through the past handbooks, you'll see that there is translation questions. Remember, even though the question we just saw uses the word translate, it doesn't mean that a translation question has to use those words. And by the way, that's the difference between SHSAT 8 and SHSAT 9, where SHSAT 9 might talk about a function, or in the case of a line, a linear equation, whereas SHSAT 8, that still might be the solution to use y equals mx plus b, but it doesn't actually mention the name. For instance, a classic example I keep using is like a cell phone plan. You may pay $50 a month plus $10 once you go over like 100 megabytes or something, or 10 gigs or whatever, right? That's an equation of a line. Y equals mx plus b. B is your base fee, is your price per month, $50, and the slope m is the cost that it's going to cost you per megabyte, so it might be 10, and x is going to be the actual number of megabytes you used, right? So so SHSAT 8 doesn't really use those notions. On the same note, just to use SHSAT 9 may have an equation that it may have a word problem that can be solved, say, with the quadratic equation, but there's no requirement that you need to use the quadratic equation. And so therefore, SHSAT 9 will almost never use the word quadratic, even though in some cases that's the best solution to use, or at least one alternate mechanism to use to solve the problem, right? So, but there could also be a SHSAT 8 question where you could use the quadratic equation if you wanted to. What's good about many of these questions is there's often alternate solutions, which I suggest you guys use, because that's a way to double check your answer. Don't double check your answer by using the same strategy you use in the first place. Use a complete different strategy, and that way you have another way to double check. One of the problems with double checking a problem is if you solve it a certain way and do it wrong, you're probably going to solve it that same way and do it wrong a second time. Not always, but that's kind of what happens there. All right. So, so actually, it is mentioned. And remember, there's different forms of the SHSAT. There's not one SHSAT given out every year. So you may turn out to not have a test that not only doesn't mention transformations, but actually doesn't even use them. Remember, there's like 200 ELA topics, 200 math topics on the test. There's only 114 questions. And within each topic, there's subtopics and concepts. And there's also, once you even focus on a subconcept, you can get 100 tweaks of it. So theoretically, there's hundreds of thousands of questions they can ask you. So there's only 114 questions, and each section is only 57. So some questions do combination of stuff where they might be dealing with exponents in a word question and maybe even percents, right? They can tie all this together in a pretty little bow, or at least an ugly bow. But there's never any way to ask you about every single topic that you're supposed to be a proficient in. And that's what makes this hard as well. Not only is each question complicated in its own right, but you don't know what's going to be thrown at you. Same for the ELA part, okay? All right, so what is the equation of the line that passes through this point and that point? So there's actually a couple ways to solve this. One way is to just plug the points in. So this is x comma y. And this is also x comma y. So just for convenience, let's call this xx comma yy, because these are just notions. They're not guaranteed to be the case. Give me 1 second. I think I have you guys falling off the screen. Let me drag this to the left a little bit. All right, there we go. So we can actually plug these in and see which works. So if y is equal to minus 1/6 of minus 3, give me 1 second. Right, times minus 3. Well, the minus times the minus cancels out. We're left with 3/6, which is a half, which is what y is. So for point xy, a is good. Okay, so but we have to throw the next one in too. So we're going to have 1/6 of 3, right? So now we have to try point xxy. So we're going to have minus 1/6. Since xx is 3, that's what we're going to use there. Right, so we're going to get times 3. And that's minus 3/6, which is minus 1/2. So we can see already that we've shown that A is the answer. So we can plug both xy and xxyy into each choice to rule that out. That's kind of monotonous and taking a long time, and it's also error prone. But it's one way to solve it. And luckily, if you take the choices in order, once you see A works, you should be done. Okay, there's a second way to solve this, which is that we take to 2 points. So slope is equal to the rise over the run. Okay, another way this is normally written is it's delta y over delta x. That looks like triangle y, but it means the change in the x versus the change in the y. Okay, and normally this is considered as y2 minus y1 over x2 minus x1. Okay, the x1 and the x2 are our xy and our xxyy. Okay, it doesn't matter which you choose for y2 or y1, just whichever you choose, you have to use the same respective x2. Okay, so if you choose minus 3, then you can't go and choose minus 0.5. You have to use the respective one. So if this is x1, y1, then you have to stick within those two. All right, so that's why it doesn't matter which you choose, the subtractions will still work out. Okay, okay, so if we actually now try to, so our goal, we're trying to solve for m, y equals mx plus b, right? We're trying to solve for that. So y equals mx plus b. So we're trying to solve for the slope. So we're going to try to figure out what the equation might be, okay? Because some of these slopes actually have other stuff. Remember, because there's no b here, this is as if it's plus 0. So there's no y-intercept. This goes through the origin. Plus 0 here too. B also goes through the origin because there's no, the y-intercept is 0. So we that's a given. We don't need to put down plus zeros. Okay, so let's go back over here. So it doesn't matter which we choose. So I'm going to have my y2 being 0.5 minus a minus 0.5. Okay, and because I chose 0.5, the positive one, my other coordinate, my x2, is going to be minus 3. And then I'm going to subtract from that 3. Okay, and all we have to do is solve this now. So 0.5 minus 0.5 is 0.5 plus 0.5, or 1, right? Over minus 3 minus that gives us minus 6. So we've confirmed the slope. I'm not sure this is showing you guys screen, so let me shift this a little further. I think I'm writing into the ether. I'm not sure you guys can see that. Yeah, there we go. Okay, that turns out to be the slope. So that would, if we just approach this as the equation of a line, that rules out choice D and choice B. Okay, so what we have so far is we built this up. So we have so far y equals minus 1/6. Again, we did all the above there. That's a bad 6. What's happening? Give me 1 second. I think my whiteboard app froze up. Of x plus b. Now what we can do is insert in either one of these points, xy or xxyy, and that way we're going to determine what b is. We kind of already did that in our when we poked in the other a and b earlier, and we find that b is 0. So that just means that's our equation. Why? Because minus 166. So two strategies. The first strategy was each to plug in both points. The second strategy is to figure out the slope, plug it into the equation of the line, and then try to figure out what the y-intercept is using one or both of the points. And then that's really all it's asking us. All right, let's try to do at least one more question here. So again, these are all line-centric. Again, these apply to many exams, not just the New York State test, as well as your proficiency. So they're throwing at us, we're going to look at the illustration first. We have an XY coordinate geometry. Everything is by 1, 1, 2, 3, 4, 5 in every direction. There is a line there with a positive slope. We can make a guesstimate of what it might be. We have a -1 here that I'm looking at where this line intersects cleanly with something. It looks like it goes through 2 this here as well. So we have over 1 that way. So we have a line with a positive slope, and it seems to be our rise is 3 and our movement is that. So it turns out if we were to do a y equals mx plus b, m for this would be 3 over 1 or just 3. Now I have no idea if that's what this question is asking, so that might be overreaching to try to decide to calculate that the slope is 3, and we can plug in points here and actually get the equation, okay? Because now that we have points, we can solve it just the same way we did the previous example, if that's what they ask us. We don't know what they're going to ask us. So function j, so it's telling us that this is j. By the way, there seems to be nothing else we can do with this coordinate grid except for actually computing the slope and getting the equation of the line, which we may eventually have to do, but there's nothing else going on there. It's very unexciting. Ho-hum is on the coordinate grid. So let me shift this up slightly, drag it over slightly so you can see the question. Okay, so let me try to get all the choices in. So if the y-intercept of function r, so this is a different function, is 3/2 greater than the y-intercept of function j, okay, so we're going to stop right there. This is the y-intercept of j. It looks like it's -1. So if it's 3/2 greater, it looks like it's right here. Wherever r goes, it's higher up. Okay, the y-intercept, where it intercepts the y-axis, is 1.5 units greater than the -1 that j intercepted, which could represent that function. Okay. Well, first of all, we already computed the slope. So for that reason, the answer would be that. Okay. And we also wanted to have higher, and we decided it was between 0 and 1, and that's 1/2. So both of those check out, and that's it. We're done. We solved what we need to do here. So the answer there would be C. All right. I'm guessing, I'm not sure how people got some of the other answers, but this is a negative slope, so it'll go the other direction. So that's completely out. B flips the 3 and the 0.5, so be careful what you're doing. B is the y-intercept. See, B is not the slopes. For that reason, that's out. And somehow the person added 3 and 1.5 to get the 4.5. This is just like a mercy answer, like, have no idea what's going on, but the numbers sound right. Well, they're just terribly wrong. So for that reason, that's that. Let me see how we're doing on time. So we're 54 minutes or about there. Let me try one last question, because this is part 4 or 5 or something we're up to, but it's probably going to be many, many other parts to this. So All right, so this is busy as heck, this question. There's a lot going on here. Let me try to focus this. Whoops. Where do we go? Where do we go? All right, give me a second. I brought the page to La La Land. Okay, here we go. So this one's a problem because I normally like to look at the illustration first. And yet, there's busy illustrations. So the analysis of this, I'm just going to kind of grok that it seems to be things split into pieces. That should be our observation. There's this, 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 this. Same thing here. There's this, 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 and a curve. And the next two seem to have the same thing going on. All right, so let me get rid of what I just wrote. And we're going to have to start looking at the words here. All I can really tell is most of them seem to have this. Well, what I was about to say is not even true. I was going to say they all kind of have a positive kind of slope, but A and B doesn't really fit into that. And by the way, some are split into lines, and some don't. Some have negative slope, like on choice number A, this right here has a negative slope. All right, so let's drag this down slightly and let's start ripping the words apart because we don't. It's too busy to try to kind of try making sense out of it. So a function has the following properties: it's increasing and something. It remains constant and something. It's decreasing and something. It's increasing and something. All right. So we have it's increasing, it's constant, it's decreasing, it's increasing. So there's four parts of this. There's that. So we have to get something where that's true. All right. So basically what we're doing is we're breaking up each of these. It seems to be into categories. So this would be A. Okay. And linear. So it has to be linear. And then well actually that doesn't work. This would be A. This would be B. Each bullet is a thing. So we'd have B here, C here, and D here. And by the way, this is kind of a classic question you can get asked on many exams or in your homework or in your class. And things follow this pattern, so this is not just made up gibberish, nonsense stuff or whatever. It's real, and we just have to try to figure that out. Because you might have, for instance, this might model the how busy a store is. So like if a store closes at 9 to 9 a.m., that's going to be constant. It could be flat line. In the morning when it opens, there might be just trickling people. At noontime, it might have the most people in the store. So this is kind of where we're going on this kind of a thing like that. All right, and then not only so we have A, B, C, D, but we have X, and then we have Y here. And I don't mean this X, Y in terms of coordinate geometry, but it's linear, it's nonlinear, and then this kind of another part which is Z, where each one is actually going to kind of talk about exact numbers. So there's a lot going on here. All right. So let's just go through this. So it says it starts out increasing. So A increases, C increases, and B and D increase, and they're all linear because they're all straight lines. All right. So in terms of that, they all pass that. But now it says between -5 and -3. So anything that doesn't do that, so A goes from -5 to -3, and it starts at -6. So, but yeah, A is increasing for that. C is increasing for that. B and D are also increasing. And by the way, this ends right there, so that could be interesting. And I noticed that pattern on some of the other ones. So they all seem, if I did this right, they all seem to pass choice number A. So then it says it remains constant. So we want a flat line at that point between -3 and 0. So A is flat line from -3 to 0. C is flat line from -3 to 0. B is not flatline from -3 to 0. So B is not the answer. Okay, and then G is flatline from -3 to 0. Good. So we ruled out one. Then the next thing is it now needs to go down and be linear between 0 and 3. So A goes down and is linear from 0 to 3. This goes up. So C is no good. Even though it's linear, it goes up. And this goes down. So we're left between A and D now. And then it's increasing and nonlinear. So between 3 and 5. So on choice A, it is increasing between 3 and 5, but it's linear. So A is out. So if we did this right, between 3 and 5, what was the choice we had left? Right. This is not a line, it's a curve. Okay, so that's our answer D. All right, so we can see these questions start getting involved. This was a busy one. And by the way, this is a function. You've looked at different ways to approach this, and based on the guy's question before earlier about the SHSAT, many of you are being, if you go back to input and output tables, where this was like number n, and this might be price, right? It just might be double. So if I buy one of something, the price is $2, right? If I buy two of something, the price might be $4. Okay, but all of a sudden, if I buy three or something, it would normally be $6, but this vendor's nice, and they're gonna let us get 3 for 5. Okay, this would be a case where if we map this is up until here, this is linear, but all of a sudden it breaks off. So again, these are real life examples where this kind of stuff happens. All right, hope y'all are good. We're gonna do another part of this. Peace. By the way, for those who are watching this to the end and got to the SHSAT registration is open. Do it. Booyah.